Hi guys, today we're going to look at moles and equations, and you'll find this called reacting masses when you look at the curriculum. The aim of this is to just have a look at some equations, talk about them in terms of moles, and see what happens if you change the amount of moles of each. How does it affect the overall reaction? So let's get on with the starter. What is the equation used to calculate moles? So if you remember from last lesson, moles equals mass divided by mR. And remember, it's a really good handy tip to remember that calculation triangle so you can calculate any one of these three things if you're asked to. The next one says, how do metals conduct electricity? Well, metals, if you looked at the structure, are made up of positive metal ions. Sorry, this is very hard to draw. And what they do is donate their outer shell electrons into what we call a sea of delocalized electrons, basically the gaps between the metal ions. And because those electrons are delocalized, meaning they're free to move, they can carry a charge. So if you're ever answering a question like this, you must include the word delocalized. Otherwise, you won't get the answer. Now the last one, state 2 allotropes of carbon. Now there's many. The most common ones are graphene, diamond, graphite. Any of those would have been absolutely fine. So let's get on with today's lesson. The first thing I want you to do is a quick recap. Explain this equation in terms of moles. Just try and put the equation into words. So pause the video, then unpause for the answer. Right guys, hopefully you'll see that there is 1 mole of magnesium because there's no large number at the front. There's 2 moles of hydrochloric acid, and they're reacting together to form 1 mole of magnesium chloride and 1 mole of hydrogen. So here's the answer, check it against yours and see how well you did. Right, we're going to look at what would happen now if we change the number of moles. So for example, how many moles of magnesium chloride, so how many moles of this, would you form if the number of moles of magnesium and hydrochloric acid, so these, were doubled? So if we double this, so going from 1 mole of magnesium to 2 moles of magnesium, and from 2 moles of hydrochloric acid to 4 moles of hydrochloric acid. So how have we got from 2 and from 2 here to 4? Well, what we've done is we've multiplied by 2. We've doubled the amount. Whatever we do to the left, we must do to the right. So if we times the left by 2, we need to times the right by 2 as well. So in this case, we would get 2 moles of magnesium chloride. And for completion, we'd also get 2 moles of our hydrogen. Hopefully that wasn't too hard, because you're going to try some now of your own. Pause the video and then unpause it for the answers. Right, first one says, how many moles of water are formed if 2 moles of methane, this is methane, combust completely with oxygen? So if I change this to 2 moles, I've effectively doubled my amount. So remember, whatever we do to the left, we must do to the right. So if I've doubled the amount of methane, I need to double the amount of water. So we'd also get here 4 H2O. Now the second one says, how many moles of oxygen are required to fully react 3 moles of magnesium to form magnesium oxide? Now this one's a little more complicated. We're not just doubling the amount of magnesium, we're actually going from 2 moles to 3 moles. And that's a change of 1.5. It's effectively saying you're timesing by 1.5. And if you wanted to find out how I know this, if I find out how many times 2 goes into 3, it goes into it 1.5 times. So that's how many times I know it's increased by. So if I times the left by 1.5, I can do the same for oxygen here. So this here multiplied by 1.5 would be 1.5. And that's all there is to it, really. Right, the next thing to look at is what if you actually knew the masses of these reactants? Could you construct a symbol equation or a balanced simple equation? Well, indeed you can, and you need to know these rules. So copy them down, and then we're going to go through them step by step. So we've got an example here, and it says 8.1 grams of zinc oxide reacts completely with 0.6 grams of carbon to form 2.2 grams of carbon dioxide and 6.5 grams of zinc. Write a balanced symbol equation for this reaction. So we're going to go through the steps, and the first thing to do is calculate the number of moles for everything that you have. So that means for our zinc oxide, our carbon dioxide and our zinc. So let's get started. So number of moles, I'm going to use N for this. It's just a short way of writing moles. So our number of moles of our zinc oxide equals mass divided by the molar mass. So the mass is 8.1 grams. And the MR of our zinc oxide is 81. And if you do that calculation, you'll find out that you get 0.1. The number of moles for our next one, our carbon, well, we have a mass of 0.6 and the MR is 12. That comes out at 0.05. And if we do this for our number of moles of carbon dioxide and our number of moles for our zinc, you'll find that you get answers of 0.05 and 0.1 respectively. So I'm just going to fill this in really quick, but hopefully you get the idea of how to do these calculations. You look for the mass in the question and then you divide it by its MR, which we've worked out in previous videos. Once you've got the answers, you need to divide to get them into the lowest whole number ratio. So divide by the smallest. So we're going to divide each of these by 0.05 because that's the smallest number that we have. So divide that by 0.05, that gives us 2. Dividing 0.05 by itself gives us 1. Doing the same here, that gives us 1. And finally this one here, that is also comes out at 2. So we know that this reaction occurs in a 2 to 1 to 1 to 2 ratio. So now we know the ratio, we can write a balanced simple equation. We have 2 lots of zinc oxide reacting with 1 mole of carbon to form 1 mole of CO2 and 2 moles of zinc. And that's all there is to it. Now they do get a little more complex, but we'll have a look at one of those harder examples later on in this video. But first of all, here's a couple for you to try. The first one is easier and the second one is much harder. But have a go at both, pause the video and then unpause it for the answers. But the first one I asked you to do was this one here, and it says 4.6 grams of sodium reacted with 1.6 grams of oxygen to form 6.2 grams of sodium oxide. Write a balanced simple equation for this reaction. So hopefully you know the first thing we need to do is work out the moles of each thing that we have. So that's sodium, oxygen and sodium oxide. So the moles of our sodium is the mass, which is 4.6, divided by the MR, which is 23, and that comes out at 0.2. To work out the number of moles of our oxygen, look at the mass, which is 1.6, divided by the MR of our oxygen, which in total is O2, so 32, and we get 0.05 for that one. And the final one is our moles of Na2O. And if you work all this out, you'll find out that it's 6.2 divided by the MR, which is 62, and the answer is 0.1. So remember, the next step we need to do is divide each one of these by the smallest number, which is 0.05. Doing that will get you a 4. Doing that will be 1. And dividing 0.1 by 0.05 equals 2. Now we know the ratios, we can just apply that to construct our balanced simple equation. So we have 4 moles of our sodium reacting with 1 mole of our oxygen to form 2 moles of our Na2O. So that's a simple one done. The next one is much trickier, but stick with it and you'll be able to do it no trouble. So this one here says 2.7 grams of element X reacts with 2.4 grams of oxygen to form 5.1 grams of an oxide, X oxide. Write a balanced equation for this reaction. Now it doesn't actually tell you what X is, but that's not a problem. We can still go through each of the steps and come up with a balanced symbol equation. So the first thing to do, work out the moles of X, work out the moles of oxygen and of our X oxide. So the number of moles of X equals the mass, 2.7, divided by whatever X is, but it actually tells you the MR at the bottom here. It says the AR of X is 27. So doing that is 0.1. The number of moles of our next one, which is oxygen, is 2.4 divided by 32, and that equals 0.075. Finally, the number of moles of our X oxide, whatever that is, and that's 5.1 grams divided by 102, giving us the answer 0.05. Dividing by the smallest here, so dividing by 0.05 for each one. Gives us a 2 to 1.5 to 1 ratio. And now you notice that this one here isn't a whole number. So if you look back at your rules, you'll find we need to get all these into a whole number. To do that, we can multiply each one of these by 2. And we'll get into a whole number. So the ratio for this reaction is a 4 to 3 to 2. But there's a couple more steps that we need to do. So I'm going to get rid of this drawing and we're going to go through those. Right, so I just said that the ratio for this is a 4 to 3 to 2. And if we was to write a balanced equation using this ratio, it would look something like this. It would look like 4 moles of X reacting with 3 moles of oxygen to form 2 moles of our X oxide. But this X oxide isn't a symbol, so we need to do something else to try and work out what the actual formula of this X oxide is. Now you know that you have 4 atoms of X and 3 times 2, so 6 atoms of oxygen. So in total, that's what you have when you start the reaction. When you finish the reaction, they bond together and they form 2 moles of our X oxide. So each one of those X oxides must be half the amount of these. So each X oxide must be X2O3 because we have 2 lots of them. And if we have 2 lots of these, 2 times 2 is 4 and 2 times 3 is 6. That completes the ratio. So the actual balanced symbol equation you need to write is 4 moles of X plus 6 moles of O2 goes to give 2 moles of X2O3. Now, like I said, this one's a bit more tricky because it does have those extra steps in. But watch it again, try and take it in, and you'll be able to do these in no time. I'm going to leave you with 4 questions to have a go at to see if you've been keeping up. If anybody wants any worked examples, just put a comment in the box below and I'll get back to you. See you later.